Hello, this is Eric with Easy Science, science made as simple as possible. Today we're going to talk about the enhanced Fujita scale. The Fujita scale is designed to measure the strength and severity of a tornado, and it was originally created by Dr. Ted Fujita in the 1970s, who is also known as Mr. Tornado. The Fujita scale was different from your typical hurricane scale because the hurricane scales measured the wind speeds of the hurricane, but that's not what the Fujita scale did. Rather, it determined the strength of the tornado based upon the severity of the damage left behind by the tornado. And this is because tornadoes aren't as large as hurricanes, and they move around, and they may only exist for seconds or maybe for minutes. Some don't touch the ground, and the wind speeds are very high and can damage equipment. So it's very, very difficult to determine the actual wind speed of a tornado. Originally, the Fujita scale was designed only to assess the damage from a tornado to specific types of structures, namely houses. But now it's been expanded to the enhanced Fujita scale that also looks at the damage to other types of structures, such as concrete buildings, trees, or to cars, or to even trains that can be blown around. But it still centers on the structural damage to a house that was site built, as opposed to like a trailer or a mobile home, and one that's been attached to the ground. So let's look at the EF scale, the enhanced Fujita scale, which goes from EF0 to EF5. It's important to keep in mind that when you're designating a tornado's EF rating, you're looking at all of the damage caused by the tornado and then basing that rating upon the highest level of damage caused by said tornado. So you may see damage ranging from EF0 all the way up to EF3 on one tornado, and then that means that tornado would be rated as an EF3. So let's talk about the lowest rating of tornado, the EF0. An EF0 tornado, by definition, does not cause significant structural damage to a well-built, stick-built house that has been attached to the ground. So in this case, you can see that some smaller trees were uprooted, and that fits within the EF0 classification. And here you can see a large branch or piece is broken off of a tree. It has fallen on a house, but the house has not received serious structural damage. The roof is still there. The windows and doors aren't broken. They might need to have a new roof covering put onto the house, but there's only cosmetic or superficial damage, and that is the hallmark of an EF0. The wind speeds tend to go between 65 to 85 miles an hour. Over half of tornadoes fall into the EF0 category. Moving on to EF1, you start to see some real structural damage to a house, but at the same time, none of the entire outer walls have been removed. For example, in this picture, the roof has clearly been damaged, but much of the roof structure is still intact, and no outer walls were completely removed at all. The damage here is unusually bad for an EF1 in this picture, and that's because this house wasn't actually attached to its concrete foundation, so the relatively weak winds were able to just push the house to the side. This is actually why you don't want to be in a trailer park or in any kind of like detached vehicle type home during a tornado, because it can be lifted up and it can be thrown and it can be moved with relative ease. And this is why tornadoes affect trailer parks so badly, so much more than with stick-built houses. Wind speeds are going to be in the 86 to 110 miles an hour range usually. Now we're on to EF2 tornadoes. EF2 and higher tornadoes account for less than 15% of all the types of tornado out there. In order to be categorized as EF2 damage, you're going to have at least one outer wall, that could include a roof, being actually removed. And here in this picture you can see that just the top layer of the roof wasn't removed. The roof is essentially removed, and for this reason this site would be rated as an EF2, and these winds are also strong enough to lift a car off the ground. So now you're starting to get some really frightening wind speeds between 111 and 135 miles an hour that can actually cause real damage to a home and can actually put you in danger even if you are inside of a well-built home. So you'll remember that if an outer wall is removed, that's an EF2. But if an inner wall is removed, even one, then now you're looking at EF3 damage. In this case, you're looking at a high-end EF3 because not only were some of the inner walls removed, actually almost all of the inner walls are just plain gone. So this is close to EF4 damage, but there is still a wall standing, and so it is therefore EF3 damage. Also, at this wind speed, so 136 to 165 miles an hour, a car can be picked up and actually thrown some distance. As you've probably guessed, EF4 means that all parts of the house have been knocked down. There are no walls, inner or outer, standing, and so the house is just a pile of rubble. At this point, the wind speeds are getting typically higher than most hurricanes, 166 to 200 miles an hour. And large objects like cars can be thrown very long distances. Trains can be picked up and thrown. And then you start to see some of the crazy damage from small objects being turned into missiles, like a record sticking into the side of a phone pole or a drinking straw being shot through a wooden board. Crazy stuff like this. So now you may be aware that there's yet another level to the enhanced Fujita scale, and you might be saying to yourself, well, how can it be worse than that? There's nothing left of the house. The house is just pieces of house. So how does the damage to a house get worse than that? And this picture shows you the answer. In EF5, not only has the house been completely demolished, but the winds have blown what little pieces are left of the house away, leaving clean foundations. Look at this foundation of this house. You could almost eat dinner off of the foundation of the house. It is so clean. And vehicles can be thrown over a mile away. That's 1.6 kilometers. And typically, you'd have to have wind speeds over 200 miles an hour, which is 322 kilometers an hour. So actually, the wind speeds from a tornado can far exceed that of a hurricane. But fortunately, hurricanes are very localized. But when they do touch down or when they get close to the earth, they can just do absolutely mind-blowing damage to the towns and the people and the lives of the people who live there. Probably one of the worst examples of this that I can think of, one of the ones that sticks in my mind the most, would have to be the Greensburg, Kansas tornado in 2007. And this is a picture of Greensburg, Kansas, right here, with just a small town, leafy, pleasant, typical small town America. But after May 4, 2007, it looked like this. There weren't any leafy trees left. There wasn't a town left. The town was gone. This is a Greensburg before picture from Google Maps, and this is after. And you can just see the devastation. The tornado just touched down right there on the town and went through the town. And a lot of people think, oh, the base of a tornado is very small. No, I mean it can be a kilometer wide, the base of this tornado. And anything this tornado touched, it destroyed. As in 95% of all the buildings in Greensburg were destroyed. There was a Greensburg the day before, and the day after there just wasn't a Greensburg. So looking at this ground level picture of Greensburg immediately after the tornado, you can see a variety of damage ranging from this EF2 here, where it appears just the roof has been removed, all the way over to this EF5 right here, where you can't even see evidence that there was a house there at one time, and a lot of EF4 scattered just everywhere. So that's how you rate a tornado, using the EF scale based upon the damage that was left after the tornado has gone. Well, that's the end of this video. If you learned anything or enjoyed this video, please like and subscribe. Also, if there are any other topics you'd like to see covered, please just leave a comment below. I hope you have a great day.